Welcome back to Science 10. This is the fourth installment in the CD3 booklet, section 2.10, Limits on Population. Now, hopefully you watched the video on the Australian mouse plague and saw how that population got completely out of control in a very short time. And this whole section kind of relates to that in discussing such things as biotic potential and carrying capacity. So field mice, they have litters with 6 or more pups. The little ones are called pups. They can reproduce every 6 weeks, which is extremely fast. It only takes 6 weeks for a mouse to become sexually mature. In 6 months, a population of 20 mice could become a population of 5,120 mice. That's amazing. If you see 20 mice, 6 months later could explode to that, assuming that the resources are there. Mice have been around for millions of years, so why is it that when you look out the window you see grass, trees, birds, and squirrels, you don't see a carpet of mice over and over again like in that video? The reason is that there are limits on all populations, including those of the mouse. So biotic potential, one of those limits on population is imposed by the species itself. Species vary in their capacity to reproduce. Biotic potential is the maximum number of offspring that a species could produce if resources, of course, were unlimited. So during those specific growing seasons in Australia, the resources become unlimited for the mouse. But of course, that always isn't true. You've seen how quickly field mice reproduce, but many animals have a much lower biotic potential. For example, mature female black bears give birth to 1 or 2 cubs after a gestation period or growing period of 7.5 months. Generally, bears take at least 2 years to mature, during which time their mother will not give birth again. So biotic potential, 4 factors it's limited by, if we take a look here. First one is birth potential. And what we mean by that, the maximum number of offsprings there means babies, etc., which is birth. So for example, whooping cranes lay 2 eggs per year, but only 1 generally survives. Okay, so birth potential, maximum number of offsprings per birth. Second factor, capacity for survival. How easy is it to survive? So that is the number of offspring that eventually reach an age in which they can reproduce. So the female sea turtle lays many eggs, but only a few of those offspring ever reach the age of sexual maturity. Third, procreation. So that represents the number of times that a species reproduces per year. So you saw the mice there. Every 6 weeks we can become sexually mature and then of course reproduce quite often. So elk mate once per year during the fall, so the number of times that a species can reproduce. The mouse, many times per year. Length of reproductive life, so the age of sexual maturity and the number of years that you can actually reproduce. The African elephant reaches sexual maturity in about 15 years, but can reproduce until they are 90. Wow. So those are the 4 factors there that deal with biotic potential. Limiting factors. The environment provides factors that, of course, limit populations for attaining their biotic potential. So not only the species itself with these 4 factors, but of course where they live affect how the population is affected. So any resource that is in short supply is a limiting factor. So we should highlight that. A resource that is in short supply can limit things. Food, water, territory, the presence of pollutants and toxic chemicals are all limiting factors as shown in the table. So of course those can be broken down into non-living and living. So factors that that generally cause a population to increase. Some of those things include, if we're talking about non-living things, favorable light, favorable temperature, favorable chemical environment, and of course vice versa there if you're looking at things that cause a population to decrease, too much or too little light, too cold or too warm temperatures, unfavorable chemical environment. If we look at living things, things that cause a population to increase, sufficient food, low number of predators, few or weak diseases and parasites, and ability to compete for resources, versus living things that cause a population to decrease include such things as insufficient food, a lot of predators that are going to eat them, many strong diseases or parasites, or inability to successfully compete for resources. Okay, so for example, a fern plant produces more than 50,000 spores in a single year. If all fern spores germinated, fern plants would cover all of North America within 2 generations of the first plant, which is quite astounding. This doesn't happen though because limiting biotic and abiotic factors come into play. If the weather is wetter than usual, the soil is moist and many fern spores can germinate, so that fern population will increase. But a return to drier weather will not prevent the spores from germinating, but will kill the plants in those exposed areas, so the population goes down. The presence of many grazing animals, of course, will eat the ferns and reduce the population. But if there are fewer grazers, the population will grow. Fluctuations like these, caused by one factor, can occur in natural ecosystems. However, most populations are affected by more than one factor at a time. All right. Carrying capacity. Populations fluctuate regularly due to the interaction of many biotic and abiotic limiting factors. However, communities do tend towards stability. Stability is achieved when an ecosystem is in equilibrium, when none of the population exceeds the carrying capacity, exceeds what they should be able to do. And of course, in Australia, they had favorable conditions in which the most population actually exceeded what they should have been able to naturally do. The carrying capacity is the maximum number of individuals of a species that can be supported indefinitely by an ecosystem. So how much could survive in that area? The carrying capacity for any species is determined by the availability of resources such as food and water. And of course, as you saw in that mouse video, the population can exceed the carrying capacity of the ecosystem, but not for long. So of course, in the video they took drastic measures with pesticides, but even if they didn't do that, the population would continue to increase, but eventually the food would run out and the mice would start dying. But of course, they wanted to shorten that time span, so in the video they used the pesticide. Consider the field mouse again. Imagine the population of predators is lower than usual. Suddenly the mouse population can grow. However, the extra mice will eat all of the available food. Hungry rodents soon become sickly, making them easy prey for hawks, owls, and foxes. The mouse population would then decline again, but of course it would take some time for that to happen. So in the video they sped that up by, of course, introducing the pesticide. And then again, ecosystems eventually reestablish that equilibrium that they originally had. Okay, I think I'll stop the video there. We'll come back. So the Australian mouse explosion was the first video. This is the second video. We'll come back with the final video in part 3.